Welcome to Math Challenge 432. In Math Challenge 432, we are given a square inside a right angle triangle. We are given a square inside a right angle triangle, and the sides of the triangle, two of the sides of the triangle are 16 and 24, and we have to find the side of the square, each side of the square. We have to find the length of each side of the square. What is given? A right angle triangle with base and altitude given, and inside it we have a shaded square. We have to find the length of each side of the square, and we will give you not one, not two. We shall solve it in three different ways. There are three different ways of solving this question, three different ways of finding the side of the square. Math challenge for all quantitative and numerical aptitude tests. Let us see the three methods one by one. So this is the first method. This is the shortest method, but this method requires knowledge of certain formulae. So in case you do not know these formulae, you can do by the second or the third method. But the shortest method, the first method, we will discuss now. Let the angle be theta. This angle we have marked theta. Now let each side of the square be equal to x units. We have to find the value of x. Each side of the square is x, and this angle is theta. You can see theta marked. So tan theta, we take the full triangle, the theta is the angle. So tan theta will be height by base, that is 16 by 24 or 2 by 3. So we get, taking the full triangle, tan theta equal to 2 by 3. Now let us see one more relation, and then we can equate them. Now see only the blinking right angle triangle, only the blinking part. So tan theta is equal to height by base. The height will be equal to x. You can see the blinking triangle, right angle triangle. The height will be equal to x, and the base will be, the total is 24, and up to this the side of the square is x. So the remaining part will be 24 minus x. So if you take only the blinking right angle triangle, still the angle is theta. So tan theta will be height, which is x, by base, which is 24 minus x. So tan theta equal to height by base x by 24 minus x. And earlier we got tan theta equal to 2 by 3. Now we can equate x by 24 minus x equal to 2 by 3, because each of them would be equal to tan theta. So cross multiply and solve. We get the side of the square as 9.6. Each side of the square as 9.6. The value of x. The value of x is 9.6. From this blinking right angle triangle, we got x by total 24 minus x, 24 minus x. This is tan theta, and taking the full right angle triangle, we got 16 by 24 or 2 by 3 as a value for tan theta. Now if we equate those, both the values, and we get each side of the square, there is a value of x as 9.6 units. That was the first method using trigonometry. But if you don't know trigonometry, there are two more methods. Now we have got the second method that will not use trigonometry. It will not require trigonometry. The second method. Let us see the second method. Now consider the two blinking triangles. You can see the two blinking triangles. The two blinking triangles. The blue triangle is similar to the red triangle. Similarity, not congruence. Similarity. The blue triangle and the red triangle, the blinking triangles, they are similar. Since the sides of similar triangles are proportional, if two triangles are similar, the sides should be proportional. So 16 minus x, that is this one. The full was 16. The side of the square is x, so the remaining 16 minus x. 16 minus x is to x equal to x is to the remaining 24 minus x. So 16 minus x by x equals x by 24 minus x. Now multiply the first and the last term and the middle two terms, that is cross multiply. X square equals x square minus 40x plus 384. Multiply 16 minus x by 24 minus x, the extremes of the proportion, and x into x, the mean values of the proportion. So the product of means equals product of extremes. So x into x will be equal to 16 minus x into 24 minus x. Now x square is equal to x square minus 40x plus 384. X square will cancel out from both sides. 40x will be equal to 384, or the value of x, that is each side of the square, 384 divided by 40, again giving you 9.6 units, the same answer. So we solved it by proportionality. The two blinking triangles, the blue and the red, they are similar, so the sides should be proportional. And using that a relation that sides of similar triangles are proportional, we got the value of x, that is the length of each side of the square, as 9.6 units, the same answer as before. So not using trigonometry, using triangle similarity. Now I come to a third method, neither trigonometry nor similarity. The first method we used trigonometry. The second method we used similarity of triangles. Here neither similarity nor trigonometry, yet a third method. Let us see how we can solve without using trigonometry and without using similarity of triangles. Now here we calculate the area of the full triangle. Forget the square. Forget the square. Take only the triangle. The area of the triangle is given by half into base into height. Half into base is 24 and altitude is 16. So half into 24 into 16, 192. Half into base into height, half into 24 into 16, that is 192. That is the area of the triangle. Forget the square, only the triangle. The area of the triangle is 192. Now on the right side, we have divided the figure into a blue triangle and a red trapezium. The top part is a blue triangle and the bottom part is a red trapezium. Now we will add the areas of these two figures. Area of the blue triangle will be half into base into altitude. Half into base, that is x, altitude 16 minus x. So half into x into 16 minus x, that is the area of the blue triangle. Now the area of the red trapezium. The trapezium, half into sum of parallel sides into height. That is half into the top is x and the bottom is 24. The top is x and the bottom is 24. So half of x plus 24 into altitude, that is x. So half of x plus 24 into x. So if we add these two areas, it should be equal to 192. Area of the blue triangle plus the area of the red trapezium should be equal to the area of the full triangle. So we will add these two and equate it with 192. Let us see then what answer do we get. So the blue triangle, half into x into 16 minus x plus red trapezium, half into x plus 24 into x is 192. Take half into x common, 16 minus x plus x plus 24. Minus x plus x cancels, 16 plus 24, 40. So half into x into 40, 192. Half into 40 is 20. 20x equal to 192. X equal to 192 divided by 20, again 9.6. Again we get 9.6. Half into x into 16 minus x, blue triangle. Half into x plus 24, red trapezium, total 192. Half x we take common, 16 minus x plus x plus 24 minus x plus x cancels. 16 and 24, 40. So half into x into 40, that's 20x equal to 192, or x equals 192 by 20, 9.6. So that was the third method, using neither trigonometry nor similarity, just using the formulae for areas of triangles and trapeziums.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.